Equations. Here's the thing. You guys struggle with these typically. Not maybe you guys, but in general, students tend to struggle with these. It's like literal equations are all letters in one equation. So instead of there being some numbers with x, it's like xyz plus 2z plus 3, and you have to isolate one of the variables. And for whatever reason, it's really no different than solving a normal equation, but for whatever reason, it throws you guys for a loop.
Because math does not have letters in it.
But it does. This is algebra. Algebra is about having letters in it.
Can I give up now?
No, you may not. We are going to persevere through this. Look at this. Dr. Seuss once said, "Don't give up. I believe in you all. A person's a person no matter how small."
Actually, that was Horton.
But it's a Dr. Seuss quote still. He's the one that wrote the quote.
Actually, I believe it was an elephant.
No, elephant said it.
But it's a fantastic movie. Anyways. So let's get started with that. So what exactly is a literal equation? It's the process of solving a formula. So formulas are any types of formulas you can think of there. For a given variable is called solving literal equations. One of the dictionary definitions of literal is related to or being comprised of letters. Look at that. That's what it's going to be comprised of. Comprised of letters. And variables are sometimes referred to as literals. Give a formula that you know and let's solve for different variables. So somebody raise their hand and tell me any formula that they know. Just any formula you know. Oh, Mike.
5/5 parentheses.
5/5 is 1.
What?
5/5 is 1. Did you say 5/5?
Yeah, not 5/9.
Okay. Are you trying to give me the formula for Celsius to Fahrenheit right now?
Yep. Parentheses. Yeah. Plus.
I hate this.
Wait, do we have to do this?
Just tell me. Come on.
36 parentheses. C equals C.
Is that right? I don't think that's right. So, where's your notes from Math Lab? Take them out real quick. I think that I'm just didn't. Oh, he didn't have. You know.
No, we didn't take notes.
Did he collect that?
Can we ask?
No, I can always look it up, or you can look it up. Just search Celsius to Fahrenheit. Okay, 1 second. Kaylee's searching Celsius to Fahrenheit for us.
Rest in peace, I lost my eraser.
Oh, it's.
Oh, we wrote it on the board, that's why.
Is there a formula? Try to hit.
I keep holding it.
Temperatures in degrees Celsius. For real. Put it on my desk, please.
Thank you.
Okay, guys. I don't know if this is exactly correct, but we're just going to use it for now. I don't think this is exactly correct, but it's close enough. So if this was a literal equation, notice that there's more than one type of variable in here. You're used to only having like an x, or only an n, or only a y. But now there's going to be multiple variables. So if this said solve for f, that means you need to get f isolated. What it means is you're getting f isolated. So what is the first thing you need to do? What is the first thing you need to do? Is that it or no? That's from Celsius to Fahrenheit, though. What do we have to do first? Tanari. Start by getting rid of the fraction. Do not distribute in them. So this is where it gets confusing because we're typically like, go ahead and distribute first. And all of a sudden we're going to be like, don't distribute. Most of the time. Most of the time you don't want to do that. I know. I know. Then what would you do? Grace, or not Grace, Jordan, sorry. We don't really want to do that though. We want to avoid distributing. And remember, this is multiplication here. Inverse of multiplication is?
Division.
There you go.
Oh, yeah.
This already hurts my
Finally, the last thing we need to do, remember, we're trying to get this f all by itself. So what is the last thing I need to do to get f by itself? Alyssa? is 9 over 5 1.8? That's probably what that 1.8 was.
Then I just found this. That's complete.
So it should be a 32, I think, instead of a 36. But that's okay. So that is how you would be to solve that. That is known as a literal equation. You will see a lot of formulas this year, whether it be in this class or your science classes, like physical science or biology. Chemistry would probably have more. But typically you're used to like plugging in, and then you're used to solving for the variable. But we're going to solve for the variable first. So when you're ready, go ahead and write that down and then flip to the next page.
Wait, that's the answer?
Yeah, that's the answer. Your answer is not going to look like an answer, which is why you guys have panic attacks.
I don't like it.
I know, it's like you wanted to just do that one number, right? But it's not. So that's what makes it hard.
It's annoying. You can't like plug it in.
But you can't plug it in to check it. Well, you could, but you guys would probably
Mess it up.
get really confused real quickly with that. But the point here is like you're going to have an answer that has a lot going on in it. You can't combine these because they're not like terms. You know, that's why it's like that. Okay. So we're going to solve for x. That means we're going to isolate x. What you guys may not realize is that last year when you guys were doing slope-intercept form, do you guys remember slope-intercept form? Y equals mx plus b?
Unfortunately.
Sometimes they weren't in slope-intercept form, right? And you had to put them in there. You were solving a literal equation then. It wasn't a complex one, but you solved literal equations before without them being directly called literal equations. So if we're going to solve this literal equation for x, we have to move the pieces that are farthest away from it first. So Grace, what is the first thing you would do? Subtract 3. Okay, we should be paying attention, boys. Okay, again, we're trying to get the variable x on its own. What? Riley.
Then we add 2.
But 2 isn't being added or subtracted, it's being, what's the inverse of multiplication?
Divided.
So you're dividing by 2.
Sure.
So you can write this problem like this. That's one answer. Or you could split it and put the negative 2 underneath both of them and divide all pieces. Or you could simplify that by moving the negative to the top. 2 negatives make a positive. So this is 2 negatives, so that makes a positive. So this could be like this. I would accept all of those answers. I would accept all of those answers.
Really don't make a positive.
In sentences, 2 negatives make a positive.
Yeah, I don't.
If you say not, it actually makes it a positive.
Not.
Yeah.
That is not.
It's like that in English too, like in your English language,
Double
you know,
negatives.
double negatives, yeah.
Oh, okay. I understand. Like you're not stupid.
So
That was the first thing that came to my head.
did you just call them stupid then?
I don't know.
Not.
You're not stupid means you aren't stupid, but then you said it again, so they are stupid.
I don't know.
Okay, so, anyways, in this one here, we're going to isolate y. Gianna, what is the first thing you're going to do to get y alone? Okay, but 3y, the y's with that, and we want to get y alone. So we don't want to move that piece. We want to move pieces that don't involve the y. So what should we actually move first? Subtract 2x. Colin, now what would you do to get y alone?
Divide 3 on each side.
Yeah, so there's a few different ways you can write this up. You can write it as y equals negative 6 minus 2x over 3. Or you could split What's negative 6 divided by 3? So that would be negative 2 minus 2x over 3. So either one of those answers works. This one doesn't work because it's not simplified all the way, because you can divide 3 into 6 twice. Okay, so that's why that one's like that. Justin. Where? Right here? Oh, that's just saying this is the variable you're solving for. So it's ending the literal equation, and that's the variable you're solving for. Does that make sense? Other questions? Okay, RC. We need to get A alone. What do you want to move first in number 3? Do I need to slow down?
No.
Okay. So we're going to subtract B from both sides. Shh. No one should be talking. Emma, we're trying to get A by itself, so then what will we do? Not yet. The C's still in the way. We can't divide by 2 yet. So what do we have to do with that C there? Can you add C to 7 or B?
No.
No, they're not like terms, so don't try to combine unlike terms. Remember, a like term has the same variable and the same exponent, and that's when you can combine them.
The answer be that.
So angry. What do you have to do next, Justin? So your answer can either be A equals 7 minus B plus C over 2, or you can split each one and give the 2 underneath each of those pieces. So it could be 7 over 2 minus B over 2 plus C over 2. None of those simplify, so that would just stay there.
Oh, the next one. I really lost all hope for my order.
Yes, I know it.
I think you guys are just overthinking the next one, because that one should be
Oh, wait,
pretty
never mind.
straightforward.
Oh, I think I know.
I get it now.
Cassie, can you help me isolate?
Help me.
Cassie, can you help me isolate R? Get R by itself.
Just divide 2.
Can D divide into T at all? Nope, so you're already done.
Well, okay, never mind.
Okay, look at those and see what questions you have for me before we move on to the next slides.
Your fractions on that homework.
Probably.
I don't get this at all.
You don't. So what's, guys, please stop for a second. Please stop talking. What's confusing you? Let's pinpoint a specific spot. Like, you need to ask an actual question so I can help you. Like, look at number 1. Look through that work and see what's confusing you there. Do you understand why we subtracted 3 first?
Yeah.
Okay. Do you understand why we divided by -2?
Yeah.
Okay. You can stop there if you want to. The other ones are just simplifications from there, but if you stopped there, I would give you the points. Okay. You've isolated x, okay? For number 2, do you understand why we subtracted 2x on both sides?
Oh, yeah.
First. And why we didn't divide by 3? Do you know why we didn't divide by 3 first?
Did you had to isolate it?
Right, and the 2x is the farthest away. Also, if you're dividing by 3, the 2x is in the way still. So we subtract that to understand why we divided by 3.
Yeah.
So if you leave it in that first box that's there on the left, you can keep it like that, or you can simplify it. That's what the other box is.
Okay.
Is that making a little bit more sense to you?
Yeah.
They are confusing. It's not. We're going to spend another day on this. I have an activity we're going to do tomorrow. I got to bring candy in so that I can give you guys candy for stuff. But we'll do. I think I have like dum-dum suckers at my house because I use them to like give to my daughter when we go shopping to distract her. I'm sorry. I don't have Smarties. I don't give my daughter Smarties.
Better than stupid Smarties.
Okay.
Yeah, I know. I feel like she's trying to say something.
No, I'm not. It's literally what I have at home because I give it to my daughter when I go shopping so that she gets distracted.
The thing is, if we get it right, why are we getting it done?
It has. You're just some. All right.
Get every comment.
Lexi, what would I do first in number 5 to get H by itself? What do we need to do first?
Times SIP.
So if there's something in the denominator, you want to remove the denominator first to be able to answer be able to solve it. Because you can't subtract n right now because that p is in the way. Do you guys see that? The denominator is trapping anything from the numerator from moving. You have to get that denominator out of the way, and to do that you multiply, because the inverse of division is multiplication. They are. Mike, what would you do now? Trying to get h alone there. That subtract what? Subtract n. Can you subtract? Can you do mush mp and n together? No, they're not like terms, so it would be mp minus n. Yep. Josh, number 6, what would you do first to get a by itself? What? You got to get rid of that denominator because you can't move the 4 yet until the denominator is out of there. So what do we do to get rid of the denominator? So we got to multiply the whole entire denominator, which is in parentheses, to both sides. Because it's an expression of more than one term, you need to multiply it to both sides. So that's a minus 4 equals 5 times b plus 2. Because those cancel out. Brian, what would you do now? So there's 2 answers. You can write this up. You can write it as a equals 5 times b plus 2 plus 4. I'd accept that. Or you could distribute and simplify. So if you distribute the 5, you'd have a equals 5b plus 10 plus 4. So a would be 5b plus 14. So either of those answers are acceptable. Okay, we need to get y by itself. What would you guys want to do first for this one? Raise your hand if you want to tell me what you would do first. Colin?
Would you multiply the whole equation by -3?
You can multiply it by -3, +3. It doesn't matter. He's chosen 3 because that would get rid of that fraction there. So if you multiply every piece, I'm just going to do 3 here. I guess he said -3. We can do that. I'll get rid of the negative. So we multiply every piece, anything separated by addition, subtraction, or an equal sign by -3. So that's -30 plus y equals -12 minus 18x. Look at that and see if there's any questions there so far. Jayla, what would you do now? Oh no, we're solving for y, and what do you notice in the next one? Ah, y is on both sides. What do we do when y is on both sides? What do you think we have to do first here? What do we have to do, Jordan? You want them all on the left side? So we have to combine them. If they're not together yet, we have to combine them. So we use the inverse. The inverse of addition is subtraction. Riley, what would I do next?
You subtract 2x on both sides. And you get that.
All right, see what questions you have for me there before we do some Word problems. Again, we're going to be practicing this skill tomorrow too. Lexi?
So whenever we get the variable alone, if it's a negative, do we have to multiply it by?
You have to multiply everything by -1 or divide everything by -1. Either way. Yep. Yeah, because the variable is technically not alone if there's a negative there, because it's a -1.
That was the most confusing thing.
Any word problems on it? Or is it just equations?
Thank God we don't have to do math like in real life.
I'm so mad at you, Brandon.
There's one.
Yeah, like us.
Okay, as long as there's no more than one.
Any of this is
Okay. In a baseball, we are inside of a baseball now. A player's batting average is calculated using the formula batting average equals hits over at-bats. And it is amazing if you can even get anywhere near a 400 batting average in baseball. So unlike most things where you want to get really close to that, 100% or whatever, baseball is not like that. Okay, so we're aware of this. All right, so rewrite the formula so that we have variables for each thing. So, RC, what do you want to call batting average? Which variable? B, okay. Jayla, what do you want to call hits? And Colin, what do you want to call at-bats?
A.
You guys are very creative.
You put A for batting average when she said B.
It
Oh.
makes it easier so we know what we're talking about.
I said B, but I wrote the letter A there.
If we wrote random variables, we could have gotten really confused.
So B equals H over A.
What does at-bats mean?
You're about to hit.
You're,
Okay.
I was gonna say, you're in the batter's box and swinging your bat. Okay, solve for the variable that represents at-bats. So which one represents at-bats for us? A. So that means we have to solve for A. Well, this is a little bit trickier than most of them because A is in the denominator. So what do you think we have to do first?
Multiply everything by A.
You are so smart. Thank you. Seriously, most kids don't get that right away, but yes, you have to get rid of the denominator first. So we have to multiply both sides by A. So we have AB equals H. That gets rid of any of the fractions that are there. So now we can really get A alone. Riley?
You divide B.
You would divide by B.
Yeah.
So smart.
You're smart. You're smart. You're smart.
So find the number of times a player has batted, so at-bats, so we're finding the at-bats. If he has hit 24 times and has a batting average of .320, which is pretty good actually. What is our batting average, B? So we are finding A, and we're going to use A equals H over B because A is already solved for. For us, H is 24, and the batting average is .32. So go ahead and do 24 divided by 0.2320. And 75 represents what?
What?
So 75 at-bats, right? So over 75 at-bats, this player has a 320 average. Bless you. One more problem and I'll get you guys your homework. Okay, a rectangular solid has a base with length 6 centimeters and a width of 4 centimeters. If the volume of the solid is 72 centimeters cubed, find the height of the solid. First of all, who knows how to find the volume, which is like if you filled it up with water, of a cube or a rectangular prism? Length times width times height. So the volume is length times width times height. So V is volume, L is length, W is width, and H is height.
That's a lot of work.
Okay, so it wants us to find the height. So which variable are we going to have to solve for in our equation? Grace. No, why do I keep calling you Grace? Goodness gracious. Jordan. H. Solve for H. So we're going to do that in the next part there. So how can we get H alone? What can we do? Alyssa? Yes, and it's important that you guys divide both of them at the same time, boys. It's important you divide them both at the same time. Do not divide L and then divide W. If they're already being multiplied together, divide them as a group. So we're going to divide by LW. So height equals V over LW. So now we can plug into our formula that we just got. We got our volume is 72. Our length and our width are 6 and 4. We have to multiply 6 times 4 first. So what is 6 times 4?
24.
So what's 72 divided by 24?
Is it 3?
I think so.
Yeah.
And it would be centimeters. All right, so go ahead.